On May 15th, 2026, NASA released a single Hubble image of a galaxy called NGC 1266, sitting 100 million light-years away in the constellation Eridanus. And astronomers are calling it one of the rarest catches of the decade. Not because of a supernova, not because of a black hole ripping a star apart on camera. Because Hubble caught this galaxy in the middle of something that almost never gets photographed. A transformation 500 million years in the making, still in progress, that even the scientists studying it can't fully explain. Stay with me, because the deeper you go into this one, the stranger the timing gets. If you're new here, this channel breaks down real space discoveries in detail. No filler, no science fiction, just what the data actually shows and why it matters. If that's your thing, the subscribe button is right there and it costs nothing. Let's go back to the beginning. To understand why one dusty, spiral-armless smudge of a galaxy has astronomers this excited, you need to understand what most galaxies actually do for most of their lives, and how rarely any of them get caught doing something else. Most galaxies fall into two tidy categories. There are spiral galaxies, bright, blue-white, humming with young stars, arms wound through them like a pinwheel caught mid-spin. And there are elliptical galaxies, smooth, reddish, quiet, made almost entirely of old stars with virtually no new ones being born. For decades, astronomers treated these as two separate populations, almost two separate species of galaxy, but that was never quite right. Spirals don't stay spirals forever. Something, eventually, shuts the star. Forming machinery down, and what's left behind looks a lot more like an ellipse than a pinwheel. The problem is, nobody had a good direct look at the machine actually shutting off. You can see the before, a galaxy mid-starburst blazing with newborn stars. You can see the after, a quiet elliptical done with all that. What almost nobody gets to see is the during. Astronomers call galaxies caught in that narrow window post-starburst galaxies. And here's the number that makes this land. They make up roughly 1% of the galaxy population in our cosmic neighborhood. Read that again. 1 in roughly 100 galaxies you could point a telescope at is currently caught between identities. And even fewer of those are close enough and clear enough to actually study in detail. But knowing a transitional window is rare is one thing. Understanding why it's rare is another. And that's where this stops being a simple statistic and starts being a genuine puzzle. It's worth pausing on why that rarity even exists, because it's not a coincidence of geography. It's a coincidence of time. If the shutdown process that turns a starburst galaxy into a quiet elliptical only takes a few 100 million years, which is genuinely brief on a cosmic clock that runs in the billions, then at any given moment, only a tiny sliver of galaxies will happen to be caught mid-transition. It's the same reason you rarely see a photograph of a caterpillar half dissolved inside its own chrysalis, not because it doesn't happen to every single one of them, because the window is short and the population is enormous, so the odds of catching any one individual in that exact phase, at that exact moment, are stacked against you. NGC 1266 beat those odds, and Hubble was there when it did. Here's what the image actually shows. NGC 1266 is classified as a lenticular galaxy, a category astronomers treat as a kind of evolutionary bridge, structurally caught between a spiral and an ellipse. It has the bright central bulge and flattened disk you'd expect from a spiral. What it doesn't have is spiral arms. The face of the galaxy hints at that pinwheel structure without ever committing to it, like a shape trying to remember what it used to be. Reddish-brown clumps and filaments of dust partially obscure the disk, and behind that dust, the light of distant background galaxies bleeds through in scattered points of red, blue, and orange. It's not a violent image, it's a quiet one. And that quietness is exactly the trap, because a galaxy this quiet on the surface is hiding something considerably more aggressive underneath. So what actually happened to it? The answer starts with a collision most people would never notice if they were standing right next to it. Astronomers now believe NGC 1266 collided with a much smaller companion galaxy roughly 500 million years ago. Sit with that number for a second, because 500 million years sounds enormous by human standards, and it is enormous by human standards. It's older than the first vertebrate animals crawling out of Earth's oceans. But on the timescale a galaxy operates on, 500 million years is recent history. It's not ancient prehistory to NGC 1266. It's practically last week. This wasn't a head-on collision between two roughly equal galaxies, the kind of merger that reshapes everything and takes billions of years to settle. It was a minor merger. A smaller galaxy absorbed into a bigger one. And minor mergers, it turns out, can still leave a wound that reshapes an entire galactic system. Here's where this stops being a story about a pretty dust-veiled photograph and starts being a story about violence on a scale that's genuinely hard to picture. When that smaller galaxy fell into NGC 1266, its gravity compressed clouds of gas and dust that had been drifting quietly for who knows how long. Compression like that, on a galactic scale, does one thing extremely well. It ignites stars. Not a few stars. A firestorm of them, all at once across the galaxy. The astronomical event astronomers call a starburst. Picture the difference between a campfire and a structure fire. Except the structure is hundreds of light years across, and the fire is thermonuclear fusion igniting in thousands of places within a geologically short span of time. That's what a starburst is. That's the before state this galaxy was almost certainly in, sometime after that merger. And before the image Hubble just took, the merger didn't just light a fire, it also fed something far more dangerous than any number of new stars. Gas and dust don't only fuel star formation, some of that material gets funneled inward toward the gravitational drain at the center of every large galaxy, the supermassive black hole. NGC 1266's central black hole, astronomers now believe, received a substantial meal from that same merger. And a black hole that's actively feeding doesn't stay quiet. It becomes what's called an active galactic nucleus, or AGN, a region blazing with radiation as infalling material heats up before crossing the point of no return. And critically, a region capable of launching powerful outflows of gas and energy along its rotational axis, like Twinwu. Cosmic fire hoses aimed straight out of the galaxy's core. The same merger that triggered a burst of new star formation also woke up a black hole capable of undoing that star formation entirely. NGC 1266 didn't just get lit on fire. It got lit on fire by something that was simultaneously arming a mechanism to put the fire out. That's not a metaphor. Astronomers reach for lightly. It's the actual physical sequence researchers believe played out in order over the last 500 million years. And that's the part where the story turns from history into an active crime scene, because the fire and the mechanism to put it out are both still running right now, in the present tense, in an image NASA released this year. This is the part of the story where the mystery actually starts. Using Hubble alongside other observatories, astronomers detected a powerful outflow of gas streaming out of NGC 1266, along with clear evidence that the space between its stars is shocked and highly disturbed, turbulent in a way a calm, settled galaxy simply isn't. Whatever star formation is still happening in this galaxy has been squeezed almost entirely into its central core. Beyond that core, across most of the galaxy's disk, starbirth has all but stopped. The astronomers studying the data believe the supermassive black hole at the center is actively suppressing new star formation by stripping away or ejecting the very gas that would otherwise collapse into new stars. In plain terms, the black hole isn't just sitting there. It's actively strangling its own galaxy's ability to make anything new. That's the leading explanation. It is not, however, a fully settled one, and it's worth being honest about that, rather than smoothing it over for the sake of a cleaner story. Feedback from an active black hole, those outflows, that turbulence, is the mechanism getting the most attention, and the observational evidence for it in NGC 1266 is genuinely strong. But astronomers who study galaxy quenching more broadly have spent years documenting other ways a galaxy's star formation can shut down that have nothing to do with an active black hole at all. Sometimes a galaxy simply burns through its available gas faster than it can be replenished, and star formation ends not with a violent shutoff, but with a slow, boring exhaustion, the cosmic equivalent of a car running out of fuel on an empty highway. Sometimes gas gets stripped away by the pressure of moving through a denser environment, like a cluster of other galaxies, with no black hole involved in the process at all. NGC 1266 shows strong signs pointing toward black hole feedback specifically. What the data doesn't yet fully resolve is how much of the quenching is the black hole's doing, and how much might be happening for reasons layered on top of it that the outflow measurements alone can't isolate. Small as it sounds, that distinction carries real weight. The black hole is suppressing star formation here, and we fully understand every mechanism driving this galaxy's shutdown. Are two different claims, and right now, only the first one is solidly established. NASA's own framing of the observations has been careful on this point, describing NGC 1266 as an ideal subject for studying the physical processes that suppress star formation, not as a case where those processes have been definitively and completely mapped out. The image is a breakthrough because it's a rare, clean look at a galaxy in the act of transitioning. It is not, on its own, a finished explanation for why that transition happens, the way it does across the broader population of galaxies like it. So if this one galaxy hasn't fully solved the mystery, why does it matter this much to the people studying it? Because NGC 1266 isn't really a story about one galaxy at all. Zoom out from NGC 1266 specifically, and there's a pattern Here that shows up again and again whenever astronomers get a rare, direct look at something that's normally too brief or too distant to observe in the act. The parts of the universe that get the most attention are almost always destinations. The finished elliptical galaxy, the fully formed star, the settled black hole. Because destinations are visually dramatic and comparatively simple to categorize. The transitions in between are the part nobody gets a clean look at, precisely because they're short-lived by cosmic standards and therefore statistically rare to catch. Post-starburst galaxies like NGC 1266 matter so much to astronomers, not because they're the flashiest objects in the sky. By most measures, they're actually some of the least visually spectacular targets Hubble points at, but because they're a keyhole view into a process that shapes nearly every large galaxy in the universe, including, eventually, our own. For a moment, it's worth sitting with just how easy it is to talk about NGC 1266 as some distant curiosity 100 million light-years away and forget it's a preview. The Milky Way is a spiral galaxy, actively forming new stars right now, the same category NGC 1266 almost certainly belonged to before its own merger 500 million years ago. Every large spiral galaxy in the universe is, on a long enough timeline, a future post-starburst galaxy waiting to happen. Star formation. It doesn't run forever. Gas supplies get consumed, disturbed, or shut off one way or another, and eventually every spiral galaxy transitions towards something quieter. NGC 1266 isn't an exotic outlier. It's a mirror pointed at a stage of galactic life that essentially every large galaxy, including ours, is scheduled to pass through eventually. We just don't usually get to watch it happen up close. Which raises an odd question for a galaxy this violent underneath. Does anything about NGC 1266 actually feel human? Strangely, yes. Buried in the public reaction to this image is a smaller detail that's easy to miss and worth pulling out on its own. When NASA's Goddard Space Flight Center shared the image publicly, the framing wasn't triumphant or dramatic. It leaned into the messiness of the moment itself, the idea that a galaxy caught mid-transformation, structurally uncertain of what it's becoming, still has something worth showing the world. Growth, on a galactic scale exactly like on any other scale, doesn't move in a straight line. NGC 1266 isn't a finished spiral, and it isn't a finished ellipse. It's neither one in public, for anyone with a telescope powerful enough to look. There's something almost unexpectedly relatable about a 100 million light-year-wide object caught in the same uncomfortable, unresolved middle that defines most transformations worth paying attention to, whether they're happening to a galaxy or to anything else. That relatable framing is a nice moment, but it's not why professional astronomers are actually spending their careers on this. What's happening behind the scenes right now is a lot less poetic and a lot more consequential. In the weeks and months since that image went public, NGC 1266 has become one of the higher priority targets for follow-up observations among astronomers studying galaxy quenching, precisely because clean examples this close and this clear are so hard to come by. Researchers are working to disentangle exactly how much of the star formation shutdown is directly attributable to the black hole's outflows versus other contributing factors layered underneath it. The kind of detailed, unglamorous data work that will never make a headline on its own. But that determines whether the leading explanation holds up under closer scrutiny or needs revision. Nobody films a highlight reel out of gas outflow modeling. Nobody puts months of spectroscopic follow-up on a trending page. But without that unglamorous work, a striking image is just a striking image. It doesn't become an answer. It stays a question with a good photograph attached to it. That is, in miniature, most of the history of astronomy. The images that go public are the accessible visual tip of a much larger, much slower iceberg of measurement, modeling, and disagreement happening underneath. The parts people remember, a dust-veiled galaxy caught mid-transition, a striking Hubble photograph, are downstream of a process built almost entirely out of the parts nobody's watching. Every rare direct observation like NGC 1266 becomes valuable specifically because of everything that gets built on top of it afterward. In papers most people will never read, using data most people will never see. And that unglamorous work isn't finished, not by a long way. Here's exactly how far there still is to go. The field itself doesn't yet have anywhere near a full catalog of post-starburst galaxies at this level of clarity, and every additional example, researchers find, sharpens the picture of how common, or how varied, this particular transformation actually is across different environments in the universe. Some of the next galaxies caught in the same window might confirm that black hole feedback is the dominant mechanism nearly everywhere it's observed. Others might reveal it playing a smaller role than NGC 1266 suggests, with gas exhaustion or environmental stripping, doing more of the work in different circumstances. But that uncertainty isn't a weakness in the science. It's the honest state of a question that's only had a small handful of clean data points to work with. and NGC 1266 just became one of the clearest ones anyone has. So here's everything in one breath. On May 15th, 2026, NASA released a Hubble image of NGC 1266, a lenticular galaxy 100 million light-years away in the constellation Eridanus, caught in an exceptionally rare post-starburst phase, a brief transitional window between an active, star-forming spiral and a quiet, settled elliptical that only about 1% of nearby galaxies occupy at any given time. Astronomers believe a minor merger, roughly 500 million years ago, triggered a burst of new star formation while simultaneously feeding the galaxy's central supermassive black hole, turning it into an active galactic nucleus capable of launching powerful outflows of gas. Those outflows, along with clear signs of shocked, turbulent gas throughout the galaxy, have squeezed most remaining star formation into the galaxy's core, and researchers believe the black hole is actively suppressing star birth by stripping away the gas that would otherwise fuel it. That explanation is strongly supported by the data, but it isn't the whole story yet. How much of the shutdown comes from black hole feedback specifically, versus other quenching mechanisms layered on top of it, remains an open, actively studied question. What makes NGC 1266 matter beyond its own small corner of Eridanus is that it's a preview of a stage nearly every large spiral galaxy, including our own, is eventually scheduled to pass through, caught this once in unusually sharp detail. Want to be here for whatever the follow-up observations on NGC 1266 turn up, and for the next rare galaxy caught mid-transformation like this one, subscribe and turn on notifications. I'll be covering it as it happens. Here's the question I'll leave you with. Knowing that black hole feedback and gas exhaustion can both shut down a galaxy's star formation, and that astronomers still can't fully separate how much credit each one deserves in a case like this, do you think NGC 1266's transformation is being driven mainly by that one aggressive black hole? Or is this a case where several quieter processes are working together and the black hole is just the part that's easiest to see? Tell me which one you'd bet on and why. I rate every single one.